Hi, welcome to an Arduino tutorial from Robojax. In this video, I'm going to show you how we can modify this pulse width modulation control module that controls the speed of motor with a knob. We're going to modify it so we can control it with either by rotating a knob with Arduino or by sending a command from Arduino. Now let's go with 6%. To change the speed of motor. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This module is one of the most easy to use speed controller that is sold with a very low price of between $2 to $15, depending where you get it from eBay, Amazon or AliExpress, and you can control a DC motor up to 35 volts and up to 10 ampere. I've made a review video of this module with all the data sheet and components have been explained. Here we're going to modify so we can control the speed of motor. The heart of this module is a 555 IC. That IC or timer is generating pulse width modulation from a variation of voltage from the potentiometer, and the output of the chip is biased with certain resistors at the gate of the MOSFET that is controlling the speed of motor. If we disconnect the path of pulse width modulation from the chip and connect a wire and then connect that wire to Arduino, then we will be able to easily use this module to control the speed of motor without much wiring and all those complexity of the other ordinary modules that are available for Arduino. This is the module that I've created a video how to use it and tested it. It's very reliable and easy to use module to control a motor. This controls the motor in only one direction. We're going to show you how you can connect this and control it with Arduino without this potentiometer from this module. Either you can put a potentiometer with Arduino or you can control it with the Arduino command to speed the motor up or down, and it will be very easy. And here is the data sheet for the IC 555 that is used for this module. Pin 3 is the output that sends the output, the pulse width modulation signal. Here is the block diagram, and here you can see it very easily that pin 3 is the output. So the signal is getting output from here to the MOSFET. We are just disconnecting this and injecting our own signal at this point, so the module will receive the signal. And here, this is the IC 555, that's a timer. This point, the dot shows pin 1, that's pin 1, 2, 3, 4, 5, 6, 7, 8. So pin 3 is here. Pin 3 has been connected from the lower side. If I turn this around, this is the IC 4 pin and 4 pin. This is pin 1, 2, and 3. Pin 3 is connected to this point, which on this side goes to resistor to this point. This is a resistor, 300 ohm resistor that I have here. And then we have another resistor to the ground, which is connected to the ground. This resistor here, which we are not going to touch. And this point is connected to the MOSFET that we have, this one. And we are going to cut this point with a sharp knife and solder our wire here, so that our signal will go through this resistor, divides with this other resistor, and reaches the power output section. We have connected the power 12 volts to the input, and the output is connected to this motor. As you can see, we see the power. Let me hold it. And here is my sharp knife. My multimeter is now in continuity tester. If I connect these two, it buzzes. And let's check this. Now if I connected the pin 2 that I've cut at this point, you can see that they are disconnected and there is no signal from it. And the signal will not reach from this to this point. And here, after disconnecting the pin 3, on this side, as you can see, we have power, but now this has been disabled because the pin 3 of this 555 chip is disconnected and signal doesn't reach the power stage. This is 7809 9-volt regulator, meaning you cannot use this less than 9 volts because the regulator has some voltage drop, so it's preferred to be used with 12 volts. And this is the output stage power controller, which is the MOSFET. Here is a data sheet for the MOSFET 7088R. The drain source voltage can be 70 volts, but in this case, because of the capacitor and other components, it cannot be used at that voltage. The amount of current it can handle, the source current is 80 ampere continuous, but with this heatsink we can go with very little. If you replace the heatsink, you can go with a huge amount of current. Let's say at 100 degrees Celsius, you can go up to 60 ampere. I will provide you the link for this datasheet as well. And here I have soldered this negative. This is a negative point when you connect your power supply. So I've connected a negative wire here that will be connected to the ground of Arduino, and then I've connected a wire here that is going at the tip of resistor. The other option will be to remove this pin up and solder the wire here, but that will make the resistor unstable and it will bend many times and it will break. So I carefully soldered it here, and it's not touching this path. It's very clear from that, so we should be good. Now let me explain the code where we have defined pulse modulation pin 1. That's pulse modulation pin. This is outputting, and I have defined it as pin 5. Make sure to select the pins that has this tilde. Pin 3 can be pulse modulation, 5, 6, 9, 10, 11. This tilde, 8 for example, cannot be used as pulse modulation pin. And then we define the control pin. If you want to use external potentiometer, will be connected to analog 0. You can define anything between analog 0 to other analog that is available. Inside the setup, we use this pin, pulse modulation pin 1, using pin mode as an output. So this is as if I type 5 and then output. And we initialize a serial monitor with 9600 baud in case if you want to display the value on the screen. And here we are using analog read control pin, which is the analog 0 pin. We are reading the value and storing it in a variable called pot value of type integer, and then we use a map getting that value, which is from 0 to 123, mapping it to 0 to 255. The output pulse modulation can be controlled between 0 and 255. It will 0 means 0% duty cycle and 255 means 100 duty cycle, and the result of this calculation, which will be between 0 to 255, will be stored in a variable called PWM, pulse modulation of type integer. This is commented out. I will explain it next, but this pulse modulation will come here using analog write. We put the pin and we put the value here, this value. So this will send the signal to the pin as pulse modulation, which is connected to the module, which will control the motor, and then we print this text, and then we print the pulse modulation value. So in case if you want to read it on the screen, because I know in real world application you might not use a potentiometer, and you might control it with other parameters from sensor, from other devices, so you will need to know the actual value in terms of percent. I've written this function called to pulse width modulation, and you enter your value. This 100 means 100% duty cycle. If you want 50, you can just type 50 duty cycle, and I will comment this out, then it will be activated. So this 50 will go to this function, which is in here. That 50 will come here and will become V, and using the map we get the V, which is, for example, in this case we are 50, which is from 0 to 100. It must be within this range, and we will convert it between 0 to 255 and will return this. So this line will return the value. So this will be between The 50 will be converted between 0 to 255. It will be a number which will be stored in pulse width modulation. In this case, this pulse width modulation will be replaced with a new value, so these two lines will be useless. But if you want to use potentiometer, make sure to comment this like that, and now this will be useless. And here let me show you the wiring. The two wires that I've connected, one to the pin 3, after the pin 3 to the resistor and to the ground, will be connected to Arduino, to the ground pin at this point, and the red one that is connected going to the signal is going to the pin 5. And if you remove this resistor, and if you want to use this potentiometer back with your Arduino, also you can do so. Just get male to male DuPont wire, and then now we have 3 wires. Make sure to put the middle one at analog 0, and the two other, the one that is connected to the right, because we want to go the maximum, this one that is red, and here it's orange, this goes to 5 volts, and on the other side will go to the ground. And these 2 pins will go to the power. The right side goes to the ground, and the left one is going to your voltage. And as you can see, we have power here. And for your motors, you will connect it accordingly to the pins that you want, because if you switch the pins, the rotation direction will change. Now let me demonstrate it. Now I'm going to connect the power, and this is now at the minimum, so the motor is not rotating. I will hold this because that will jump. So this works fine. As you can see, the pulse width modulation now shows 0, and as I rotate this, now it's almost at 10%, at 10 out of 255. So the motor is not rotating, and the motor starts rotating at around 19. This value will be different from motor to motor. As you can see, this didn't go to 255. Now I've connected my own potentiometer, remove the one that was available. Let me try it. And it can go to 255. Now I've commented this out, and let's run it with 20%. The code is uploaded. Let me hold it and connect it to the power. This is now 20%. Now let's go with 6%. As you can see, once you activate this line, this will be useless, and I remove the potentiometer because it will not have any effect, and these will just exist. If you are not using it, just delete them. Let's go 50%. Uploading. %. 100 now. And whatever value you want. And you can control it different ways. For example, if temperature is a variable and you want to check if the temperature is 65.4 degrees, and once the temperature is above 65, the motor should run, let's say, at 80%. And so this can be, for example, for a cooler in a pump, or cooler of fan, if the temperature is above, so this will turn on. You can also program it that it could be directly, the percentage of rotation could be directly proportional to the temperature. As the temperature increases, the pump or the fan should run faster. When it decreases, it should slow down. It will work like a feedback. But it's up to you. I'm just removing this so people are not confused. And if you're using potentiometer, again, just comment this out. I'd like to sincerely thank the following people who have supported me via Patreon. Thank you for watching. This was how to modify this 10 ampere pulse width modulation speed controller and use it with Arduino. If you found this useful and learned something, please thumb up, as this will help my video in the algorithm of search. If you have comment or question, post it at the comment section below. I try to answer and reply. And if you want to get updates of my upcoming videos, you may subscribe now.
So this works fine, and